Right, in this example, we have a simply supported beam that has a uniform distributed load and a point load of 80 kilonewtons. And we need to work out the shear force and bending moments. So if we take the moments about C, we'll see that the clockwise moments is 10 RA is equal to the anti-clockwise moments, which is 80 by 8, that distance there. And it's going to be 10 by 10, which is 100. 100 acting through the centroid is 5. So it's 100 by 5. So the reaction force at A is 114 kilonewtons. That should be kilonewtons. And then when we take the moments about A, we get 10 RC. That should be equal to 80 by 2, so that distance there, and then the 10 by 5, or 100 by 5 again, and we solve that and we get RC is equal to 66. Okay, so let's consider all the units are in kilonewtons. Okay, so I'm just going to leave out the K to make things more neater, but everything will be in kilonewtons. All right, so if I want to take a segment between A and B, so I'm going to take this segment here. Okay, and we're going to look at the forces. So the shear force from A to B, well, this is 114 kilonewtons. And actually, I might as well put this one in here. This is 66. So the shear force here is 114 minus 10x. So, okay, so it's 10 kilonewtons per meter. And if that distance there is x, that's going to be 10x. And if we want to get the bending moment between this segment, then that's going to be 140, that's acting at that distance x, that's 114x minus, so it's going to be 10x, and it's going to act through the centroid, which for a rectangle is halfway through it, so that's x over 2, and that equals 114x minus 5x squared. Okay, so that's for segment A and B. There's our shear force and bending moments. If I want to look at segment BC, so somewhere in here, well then the shear force, well, adding the forces up to the left, we have 114 minus 80 and minus 10 kilonewtons by x, so whatever this value is now, x is here in this segment. When I add that up, I get 34 minus 10x. And if I want to get the bending moment, well, it's going to be 114x. So that's that moment. Minus 80 times x minus 2. Well, if that's x, and if that distance there is 2, then that distance there must be x minus 2. So that's that. And then the uniform distributed load is 10 times x, okay, whatever that distance, acting through the centroid, which is going to be x minus 2, x over 2, I should say, which is 5x squared. So add them all up, we get 5x squared plus 34x plus 160. So that's our shear force and bending moments for each of these segments. And if I put those into Microsoft Excel, that would be my shear force and bending moment diagram.